Okay, can everybody hear me, and see my screen?
Yeah.
Okay, great, thanks. So welcome to today's lecture. Today, this is actually one of my favorite lectures. It's about the design guidelines. So we'll talk about how to do visualizations, and I'll show plenty of examples of how to not do visualizations. And so there's some entertaining ones in there. So before we get started, just some administrative stuff. Next week, on Monday, we'll have a lab on homework 3. On Tuesday, we will have a lecture on D3 layouts that Han will be teaching. On Thursday, we'll have a lecture on interaction. And for that lecture, I would like you to read the Interactive Dynamics for Visual Analysis paper by Jeff Hare and Ben Schneiderman. And we'll discuss this in lecture. The homework 3 has already, homework 4 has already been released. So doing real data, like in homework 3, we're looking at COVID data, but of course we didn't have proper labels and scales and so on. And so this here is like the first time we're doing something, let's say, useful. And it's going to be this Gapminder based data. And we'll have like a big map and that you can interact with, and then we'll have a scatter plot, and we'll have an info box, and you can kind of like dynamically decide what kind of like what data you want to plot on any of those charts, and then you can also scroll through time. So I think this is kind of like a cool homework. There's a lot of moving parts, of course, so it's not all that easy, but I think it's worth it because it's just going to be like much more exciting than what we've been doing so far. Okay, I see that people are getting having issues with the audio. Let me try to stop my video. I'm also recording on my computer now, so like worst case, I'll put this on YouTube later, and then it should be better. Is that better in any way now? Okay, let's try this. And for today, I wanted you to read this paper here, and I still, like, if you haven't, I do recommend that you read it. This is by Danielle Safir, and it's kind of like an easy read on like the stuff that we'll be covering today, how visualizations can mislead and how you can fix it. Okay, so let's get started with design guidelines, unless anybody has a question. Great, so let's get started. So the first rule that we kind of talked about already in the last lecture is use the best visual channel available for the most important aspect of your data. So just recall in the last lecture, we talked about these like different marks and channel, or different channels have different properties. So for example, position is like the most powerful visual channel, and so you should always use that if you can. If you can't, move on to any of the not so good ones, but like always just go through that list and follow that ranking to encode the most important piece of your data. So we kind of talked about this a lot last time, so I'm gonna just leave this like this here. And then the second visualization, and this is a little bit more controversial, and I'll come to this later. This is kind of like derived from a guy called Edward Tufte. He says like the visualization should show all of the data and only the data. So you should show like everything that is relevant for the visualization, but you shouldn't show anything extraneous. And I'll talk about what he means with that later. Just like a couple of recommendations. So first, there's this book by Cole Nussbaumer Knaflich, which is like a great book with simple design guidelines. This isn't like a visualization book like Tamara Manzana's one, for example, like our textbook. It's also not really covering the stuff that we're doing like in this whole lecture, but it covers what we're doing in this particular lecture today pretty well. So it's more of a charting book and not a data visualization book. But it is a good read. So if you want to learn more about what we're talking about today, that could be useful. So here are some more of Tufte's integrity principles. Some of you might have heard of Tufte. Tufte is this professor, retired professor who kind of like was a pioneer of data visualization and wrote a couple of books. He has some kind of like strong opinions, so he's a very combative person on Twitter. I think his integrity principles here are useful. Like you should show data variation, not design variation. Clear, detailed, and thorough labeling and appropriate scales are important. And the size of the graphic effect should be directly proportional to the numerical quantities, what he calls the lie factor. And so we'll get into this. This kind of all fits together into this picture of scales. And scales are really important in data visualization. So what is the lie factor here? It's like when you divide the size of the effect shown in a graphic by the size of the effect in the data. And so this is about graphical integrity. What you want to do is to that the magnitude in the data corresponds to the mark. Here's an example of a chart that doesn't really do that. So what is going on here? Why is this not a good chart?
Y-axis is cut off at 34%.
Exactly. The y-axis is cut off at 34%. And so why is that problematic? Like 35 looks way too low than it should, is what I'm reading here in the chat. So that's exactly the problem here, right? This is kind of like overstating. This is like from Fox News back in the day when the tax cuts under the Bush administration were about to expire, that like the top tax rate would move from 35% to 39.6%. But it actually looks like as if the tax rate would be like quintupling, right? Instead of increasing by 5%. So they have kind of like cut off the scale here by like just like 30% and or even more just to make a point. And so cable television will be like a source of many of the examples that I'll be showing today, because they don't seem to be using like data visualization tools, but just do some kind of like weird things with like often very obvious biases. So if we actually calculate the lie factor here, we can say that the effect in the data is 1.14. So like the tax rate would rise, the top tax rate would rise by 14%. The effect in the graphic, though, is a factor of 5. And so we can calculate a lie factor by dividing 5 by 1.14, and we have like a lie factor of 4.38, where what you really want is exactly 1, right? And so here is this chart if we just redid this with these proper scales, and that would be a much better chart, right? It kind of like shows you that we have these, we have the like the current and the future tax rates, but it leaves out some context, and this will be picked up in a video that I'll be showing in a second. So here's another chart from an Austrian tabloid newspaper. This is about people that are getting some like some emergency basic income in the city of Vienna based on where they're from. And you can see like there's Austrians in the first bar, then unknown in the second bar, Turkey, Serbia, Syria, Afghanistan, Poland, and so on. And so what's wrong with this particular chart? Anybody can spot it?
Is it actually supposed to be linear and it just looks exponential?
Yeah, this chart is supposed to be linear. So, but you're getting it something here.
The bar on the left side is going way off the page and you can't see anything.
Exactly. So the bar on the left side is clipped off, right? The label is correct, but the bar isn't. So if we actually show this bar correctly, it doesn't even fit on this screen. I have to zoom it out like that, right? So this is just like very clearly biased reporting, right? They're not trying to tell the whole story, but they're trying to say, hey, all of these foreigners are like getting our tax dollars, when in reality, it's like really a tiny share compared to what people that are Austrians in Vienna get in terms of this basic income. Of course, there's also plenty of interesting examples. Sorry for this bad positioning that I slipped here. This is a recent one for coronavirus cases worldwide. So what's wrong with this chart here? This is a little bit older, so the cases are now, of course, very different, but
The axes is still off, or are still off.
yeah, exactly. So this is clipped like somewhere that the difference between the United States and China is like was at this point in time 1,000 people out of 80,000, right? But it looks like China has way more coronavirus cases in this chart. And so you see this was a CNN post, which isn't necessarily like politically well on the same page as Fox News. Andreas has a question.
Yeah, so in that last example, when you have a bar chart that's like way larger than the rest, how do you appropriately show that? If you don't have enough space, like how do you appropriately show that without lying with your data?
Yeah, so that's a good question. So one thing that let me maybe draw on this here, right? Well, I think if you really wanted to show that data, like one thing that you could try to do was actually to do like a snake here, right? To say this would be my bar chart for the Austrians. Like it's just like a crazy idea here, right? Or you could try a log scale, but it's not going to do all that much. I think that really the framing here is more of the problem, right? It's like you could do some like part of a whole visualization. You could show something like I have like a stacked bar chart here that shows Austria and then unknown, and then you could show like whatever Poland was a big one, and then you could show something like all of the others combined. Pie chart is I'll have a couple of words to say about pie charts, but yeah, pie charts would be an alternative here. Pie charts, like just as a preview, have a little bit of a problem with many segments, especially if they're all small. So that might not be on all that great pie chart because you will have a gigantic segment and then very small ones.
What about a broken y-axis?
Yeah, if you are very explicit about that, that is okay too. Like if you say, like if this is about labeling, right? If you say, well, Austria in reality is way bigger, like there's a share of Austrians here is way bigger, you make it explicit, you write like an info box or a label, then I think that would be okay to do like that. Here is an even more extreme case, Obamacare enrollment, actual enrollment versus goal. So kind of like even more extreme here, it's actually just like factually misrepresenting the data. You can't even like argue about what the scales are. Starting scales at 0 is kind of like the simple solution to this problem, but it's not always the best one, right? So for example, here is a chart that shows the median household income in 2010, inflation adjusted dollars. And if you kind of like show this at like a zero-based scale, you don't see much of a trend. But if you show this on a non-zero based scale, you do see much more of this trend. And so the point here is to use a baseline that shows the data and not this 0 point. Like you should think about what is a meaningful baseline, right? And not always is 0, like as we talked about when we talk about interval data, not always is 0 even relevant, right? Like temperature, showing temperature on a 0-based scale isn't useful, right? You need to think more about like what is the context of the data. And so this is this nice video that Vox did, which I'm going to play here.
We make a lot of charts at Vox. And of course, charts have axes. And pretty much every time we run a chart with a y-axis that starts anywhere other than 0, someone winds up emailing to complain. You see, there's a really famous book called How to Lie with Statistics, and it contains a discussion of how you can create a misleading chart by messing with the y-axis. And it's definitely true, you can do this. Here's a chart from Fox News, for example. It's a total disaster. But the y-axis dogmatists take it way too far. The big problem with the people who lie with statistics is that they're lying to you. It's true that misleading charts are one way to lie, but the English language is also a tool that can be used for lying. And that doesn't mean we should never speak English. So sometimes you need to fiddle with the y-axis to tell a story properly. So for example, right now, the share of American adults who have a job has fallen to a generation-long low. This is a really big deal. But if you chart this data with the y-axis at 0, you can't see the change at all. Narrowing the range to dramatize what we're talking about isn't lying with statistics, it's emphasizing what's relevant. The way Edward Tuck puts it is you need to use a baseline that shows the data, not the 0 point. And after all, 0 is just a number like any other. Sometimes to make sense of the data, you need to be able to show numbers that go below 0. Halting at 0 in those cases doesn't make any sense, but extending every chart way below 0 would be crazy too. And of course, where 0 even is depends on the units you're using. If you do a chart of a person's temperature in Fahrenheit, you're likely to miss the fever if you're zoomed all the way out to 0. If you redo it as a Celsius chart, it's not quite as bad. But if you switch to Kelvin and extend everything to absolute 0, then your charts become useless. When people are really lying with charts, the main thing they're normally doing wrong is leaving out the context, not leaving out the 0. Go back to that Fox News chart. You never know from this chart that the top marginal rate was 39.6% back in the Clinton administration, or that the Reagan administration it was 50%, or that back when Eisenhower was president it was 91%. The missing 0 was really the last of that chart's problems. What they left out was the entire history of taxes in the United States. So just remember, y-axes don't lie to people. People do.
Okay. Great. So the point of this is here, like visualization can be used to lie just as language or just as statistics, just as p-hacking or anything like that. When you show something, you have to make sure that you're faithful to the data. You have to kind of like dig in, explore, look at the context, and then make decisions that are sound and that you can justify. Here's another example about global warming. So here, it looks like in this chart, it looks like the world average temperature between 1997 and 2012 didn't seem to be rising, right? So maybe global warming isn't a thing. But if we actually like frame this a little bit broader, we see that there is a slight linear trend. But if we like actually take a bigger picture, we can see that this trend is even much more pronounced. And in the recommended reading for today, there's like a nice blog post that shows you how you can essentially do something like p-hacking with just picking the right data and visualizations to kind of like show that we are actually like temperatures are falling on average in the summer for a subset of weather stations in certain parts of the United States or something like that, right? You can always cherry pick your data to show something, but you have to like use a justifiable process to actually select what you're showing. Otherwise, you're going to deceive your readers or your kind of like the people that are trying to analyze this, the data. So here is another chart. Like this is something else that I want to emphasize. What is wrong with this particular chart here?
There's no consistent time step between the chart and bars to begin with, and then also again the y-axis is skewed.
Exactly. So the big problem here is that like if you have time, you kind of need to really plot it like in sequence, right? You can't just like rearrange time arbitrarily. Like we are just really primed to see time progress linearly, and so something like that is really tricky to do. So like if you see here that there that these years just don't line up, it doesn't make a ton of sense. Just quickly see, I lost the chat window here. Here we go. Great. And this kind of scale distortion in temporal data that can be quite, you can kind of like fiddle with that, and that can be a problem. So here, for example, we have essentially job losses by more or less arbitrary quarters. Like these quarters are not, they're not like regularly spaced as they would look like in this particular visualization here. Here's another one. This is like a recent coronavirus one. So what's wrong with this chart here? It's a little harder to spot.
Could it be the y scale isn't scaling up proportionately between steps?
Exactly. So we have really bizarre steps for the Y scale, right? We have 30, like down here, we have 30, 60, 90, and then 100. And then again, 130, 160, 190, and then suddenly we have a 40-point step, and then we have a 10-point step, right? I don't even know how you would like do that other than like actually manually drawing it. So, but something like that, like that's just like a real problem if you do that. So if you replotted this chart and used the proper scale, we would get something like this. And so here you can see that the increase is much steeper than it actually appears. Also because here this is like properly scaled. One thing that is also important to think about are log scales. Log scales is something that you should use if the underlying data warrants it. Typical use case of that is if we have exponential growth curves. And so this wasn't something that people usually thought about before COVID, but now everybody, of course, cares about exponential growth curves. So like I'd say pre-2020, this was really like log scales were more of an expert tool. But now, of course, we all care about log scales. And so here are two different charts. They're the same data. The left one here is on a log scale. The right one here is on a linear scale. This shows kind of COVID cases by US states and territories around the time when New York was hardest hit. So like, what are some interpretations of these two charts, and which of them do you think is more useful, or which one would you prefer?
I think it kind of depends on your audience, you know, like what are you trying to, who are you communicating this to? That'd be my thought.
Yeah, definitely. It depends on your audience. I might even say they kind of answer different questions, right? Like the log scale chart here is really good for showing trajectories. It kind of like shows you, hey, like on which path am I on? Like even if I have only 1,000 cases in the state, in like a state like Utah, we can see how things are changing relative, like we can see how things are changing pretty well in this log scale, but we can't really see anything except for New York like dominating this chart here on the right. So the left chart here is really like, hey, if you want to make informed decisions about policy, you should probably use the left chart. But if you want to just tell people about the magnitude of the problem in New York City or in New York State, you might want to show them the right chart, right? So it's not, neither one of them is better than the other or correct. It really depends on your task, on the question that you want to ask. And if you have log scales, you have to be very explicit about them, right? So here, this chart is not bad because we have these like grid lines and the nice labels, and then we have the reference line. And so you need to kind of like bring in context to make sure that people really understand that. So related to that topic is also like normalization. So if we chart something like different US states, and if we use absolute cases, of course, New York, a state like New York and California are going to show up more likely than like a state like Montana or Utah, which has much smaller populations. So what we need to do is we need to compare apples to apples. When we compare things that are different, we need to account for that difference, right? So normalize your data. So if you're trying to do something based on like where population, the size of the population matters, you need to adjust for the size of the population. If you're trying to, let's say, visualize prices of food, it doesn't make sense to say, hey, food in like another country is cheaper than in the United States. if you don't account for the buying power of people in that country, right? So you have to kind of like normalize things, and that is often not that easy, but it is absolutely necessary. So like here's an example. This is from our world in data. I'll show this like in a second in a live demo. But here we have cumulative COVID cases, and we can see like, well, there are 3 countries here that dominate this chart. It's the United States, it's India, and Brazil. And so it looks like the situation in India is kind of like pretty bad, right? Like in the United States, we're pretty aware of that, and Brazil seems to be like slightly better maybe than the United States, still problematic, but this doesn't account for population, right? And so if we now instead plot this as cumulative cases per million, the picture changes quite a bit, right? So suddenly Brazil is actually in worse shape than the United States, whereas India has kind of like is not among the like most prominent prominent lines here anymore. So India's problem is while significant, it's not quite as big as Brazil's or the United States. And then if we see some countries here that we didn't notice before, right? So South Africa is a fairly small country by population compared to India, Brazil, and the United States. But in this chart here, it actually shows up, and there's some other ones that are kind of grayed out here in the background. So kind of like if you do these normalizations, you always have some kind of effects for small cases. And so you also have to worry a little bit about how to properly deal with those. And so really like what you need if you have a complex data analysis problem, such as understanding a pandemic, you need to get the full picture. You might need to look at more than one chart, and you might also want to provide some context. And so I actually wrote a blog post in July about essentially why dashboards that simplify things so much are not a great thing in a pandemic. And I'll put the link in the slides. The slides are already on your website. But I want to show like this particular website here. This is Our World in Data, which does kind of like visual communication of data out of Oxford University. And I really like this this tool here. So we can basically answer all of these different questions by dynamically changing things here. So for example, we can switch between what are we showing here? So we can switch between a linear and a log scale easily. So we can like see both of these perspectives, and the log scale, of course, is like shows us quite a different picture than the linear scale. We can do things like hide countries with 1 million data with less than 1 million people. That kind of cleans up things a little bit. But then we can also adjust things on a per million basis here. So if we do that, then we see these different pictures. We can switch between confirmed cases, death, and so on. And we can also step through time if you want to. So this is kind of like an interactive way where you can like play around with different kind of modalities and develop a better understanding dynamically. And it's like this website also goes into detail and provides lots of context and annotations, and it really does a very good job at responsibly communicating something that is as complex as this. Okay, so I want to move on to visualizing distributions, because that can be something that is especially tricky. So here in this particular picture, the height of the bar encodes a mean of a distribution. Which value is more likely to belong to the distribution A or B? And let me just quickly do a poll. Okay. So for this chart here, which value is more likely to belong to the distribution A or B? I see somebody saying not enough information, but this is like how this information is often reported in a scientific paper. So sometimes this is all you have. Based on that, what do you think people will interpret? So I see about 75% of people are saying B. And somebody saying equally far from the mean. So you can see the results now. And yeah, so of course, was a little bit of a trick question. If I draw the line here between B and A and then move the same line up here, it is equidistant, so it's about equally likely. But why did everybody pick B here, or why did the majority pick B here? This is called the within the bar bias. So we can plot the data faithfully, but still perceive it wrongly. So if I were to show something like this, like of course now like you already know the answer, but if I showed something like this, I think it would be much less likely that like people would say, hey, doesn't make sense, right? Like they're about the same distance from the line. So in this case, we have like it's equidistant, so I'm actually not giving you a good option here, so I'm gonna like stop that poll. But the point here is that like the bars, if something is within the bar, then we tend to perceive, if we have a bar, we then tend to perceive like a distribution to be within that bar. And so this is why bar charts with error bars to show distributions, which is super common and still like we see that in visualization papers, is actually like a really bad idea. And so in this paper, they studied the magnitude of these biases for these four conditions, A, B, C, and D here. And you can see that for like with these red lines here show you that border and shading, this one here led to like a pretty significant bias, whereas this chart here in D didn't lead to a bias, right? So we can see that people understand the data better if we show it like that compared to in the bar chart that we have here on the left side. So instead of showing something like a bar chart with an error bar, you should instead show like a mean and then something like a violin plot or even a box plot or a histogram or something like that to actually show the distribution, because you can see much more nuanced information. And we'll talk about this in more detail when we talk about visualizing distributions for tabular data. But this is just kind of like a primer of like what you need to be aware of here. So like, what are trend lines? Like we can show a trend line very easily. We can calculate trend lines easily, but it turns out that people are actually pretty good at estimating trend lines. So like that we can like algorithmically fit a trend line, but in practice for something like what you see here on the left, we don't necessarily need to. And we can also have these kinds of biases if we, so for example, we are really good at spotting trends. We can see these trends very easily, but if we use the wrong visualization, we can be like again deceived. We can like this within the bar bias doesn't only affect the bars, but it also affects something like an area chart here. So if we were to show a distribution like that, then we would have a similar within the area bias in this case. Okay, I want to move on to pie charts because pie charts they deserve their special treatment because they are so ubiquitous. And so here's a simple pie chart. I picked one that is actually like fairly reasonable. This shows a part of a whole relationship on the market share of different browsers in 2018. We have Chrome dominating it, Safari, Firefox, and then we have some smartphones that kind of like brand their browsers, seems like it. So this is a reasonable chart. What pie charts are doing is really showing us how, like, what is the share one thing like of the whole. And you see here, Chrome has a big share. So like not a terrible pie chart. We could make this chart better. So for example, the wedges, we could label them directly instead of like having a color legend. So we don't have to have the indirection. The number here, the numbers here are kind of like pushing the limit. So for example, Other versus Opera and Samsung versus Chrome. Like Samsung versus Chrome is okay to distinguish, but Other versus Opera, they are also pretty small. So I'm not completely sure which of them is which segment here, right? So we could just label that directly, or the other thing we could say, we could create fewer segments. So for example, all of these Samsung and Android and Opera and UC browser, they don't really matter all that much for the big picture here. So we could just like make the other piece bigger and focus on the ones that have proper segments. And then we also need to make sure that the labels here have contrast, because the label like 4.99 is pretty light on top of the of this light wedge. So like that's a problem. But not a terrible bar chart. But let me show you some examples of what you definitely shouldn't do. So what about this? Americans who have tried marijuana. So we have 51% today, 43% last year, and 34% in 1997. So like, what is going on in this chart here? There's so many things wrong. Anybody want to?
Doesn't add up to 100.
It doesn't add up to 100, exactly. So if something is not a part of a whole relationship, you should not actually use a pie chart, right? Like this is, and the other thing is like the title here is also deceiving, right? Like it's not that 51% of Americans have tried marijuana today. It is actually support for legalizing marijuana among people who have tried marijuana in the past. So, and this would be a much better fit for a line chart with a better label. So yeah, if you don't have a part of a whole relationship, don't use a pie chart. Here's another one, a COVID one. We have biggest COVID-19 worries are getting it, family getting it, and the economy. And again, it doesn't add up to 100%. So don't do pie charts if you have surveys where you allow multiple answers, right? This just doesn't make sense. You should just use a bar chart here and you would be fine. So this here is from Cole Nussbaumer, the person that I wrote, like that I mentioned that has this book. And she calls like pie charts, like she really, really hates them. And here's a pie chart that isn't completely terrible, but does many of the things wrong here. So this pie chart here has like a problem. First, it uses color like unnecessarily, right? Like we don't need it. And then, so we could do something like this. Why do we actually need a pie chart here, right? Like we have so many small ones, and so instead we could just show a bar chart here. And this bar chart here like communicates the data probably much better than this pie chart. One thing that like is really tricky to spot in pie charts are differences over time or comparisons between pie charts. Take a look at this pie chart and think about whether you can see any trends between or any differences between A, B, and C. And so it's like if we look closely, we can see that the red segment here seems to be growing from A to B to C, but it's kind of tricky to spot. It's not completely obvious. And so if we plot this as bar charts, we can see that the red bar is growing, and we can see the proportions of these individual segments much more clearly than we can in the pie charts. Here's just some humorous pie charts, like a pyramid pie chart. And then my second favorite pie chart is the real pie chart, the pie I've eaten and the pie I've not yet eaten. So what can we use instead of pie chart? Why? Like I'm hating on pie charts here. Well, sometimes they're useful, but what can we do instead? So here's an example. So imagine you just completed a pilot summer learning program in science aimed at improving perception of the field among second and third year elementary children. And you do like a pre and a post survey for these children. Like, how do you feel about doing science? I'm bored. It's not great. It's okay. I'm kind of interested, or I'm excited. And after the seminar, you're doing a similar survey and try to kind of like measure the effect that the seminar had. And doing pie charts here, again, it's not like that you can't read it at all, but it just doesn't show the data well, right? So if we do instead, what can we do instead? Like the first alternative would be to just show the number directly. So you could say something like, after the pilot program, 68% of kids expressed interest towards science compared to 44% going into the program. So that's kind of like the simple baseline version. If this is like the fact that you want to communicate, this is nice. Or we could do a simple bar graph where we have like before and after simply juxtaposed next to each other. We would have something like the bored people. It actually, like, your seminar increased the share of people that were bored by science from 11 to 12%. That's something that you can see here. And the other big effect here that you see is that people that didn't really think about it, that gave the answer okay, they moved, it seems like they moved into the kind of interested and excited pile. So this chart here, I think, is pretty good at communicating this particular data. Here is another alternative, like a stacked bar chart. And notice the grouping here into the three categories: bored, not great, and kind of interest, excited, and neutral, okay. So you can see that the people that have some positive feelings about science increased, while the people that have negative feelings also increased slightly, whereas the middle pack here kind of like mostly shrunk. And so stacked bar charts are often a good alternative to pie charts, especially if you want to communicate the part of a whole relationship. They're still not like the perfect solution for every case, because if you have tiny segments, you still have to take care of them. And then here's a different, completely different idea, like a slope graph. How did this, like, basically a slope graph is just like a fancy word for a line chart with 2 points. We have this before and after, and then we have these different categories, and we can see that there has been this inversion between the people that were okay and the people that are excited. Okay, so any comments on this? There was a lot of chat activity going on, and I wasn't able to follow that while I was talking. Yeah, it would be nice to see like a flow chart here to have this exact data. That is definitely true. Any other questions about pie charts? Okay, so I didn't actually want to do that. I wanted to skip that. Let me go here. So the other thing, Tufty is very like he like, remember that I said in the beginning, you should show only the data, nothing but the data. And so here's this controversy about clean charts versus embellished charts. So here we have like a bar chart. This is something like a 3D bar chart. This is something that you could do in a tool like Excel. And I'll talk a lot more about 3D later. But like, how could we change this bar chart to kind of maximize our data to ing ratio? So first, we could remove the 3D. This is like easier to read. It's also easier to create. So this is like a better chart. But then, so here's another example. This is like a bar chart where we have a lot of chart chunk, unnecessary visual elements, right? And so I could kind of like get rid of the grid lines. I could get rid of the background. I don't actually need all of that framing here. Maybe I can get even rid of the axis on the left and show little ticks on that on the bars directly. So that is now a much better chart than what we originally had with all of these unnecessary features on top of it. And so here is kind of like the absolute minimalist version of it. But so like, this is a great chart, but not always is absolute purity the right thing, right? So here is a chart about, let's say, prices of diamonds. One is like one of those infamous or famous, depending on your perspective, Nigel Holmes charts. And then right next to it is like the absolute minimalist line chart. And so which of those two here is better at communicating the data? The right one, I hear. So a lot of people like right, some people like left. This is a little bit like the chart, the Bill Gates chart about the infectious diseases we talked about, right? It is like, what are your goals? Is it really all about just faithfully communicating the data, or what's the context? Is it a newspaper? Do you want to get people's attention? The left one here is definitely entertaining and brings in context. Here's another example: the monstrous costs, the total House and Senate campaign expenditures in millions. This is from like the right chart here. Again, very simple. The left one here brings in illustrations, right? And so turns out that people actually like. So one point is about what communicates the data better. Another point would be about memorability, right? So what do you think, which of those two charts people would remember after like a couple of days? Yeah, and so it's not that they just remember the chart, but they like this paper here actually studied that, the effects of visual embellishment on comprehension and memorability of charts. Garrett, you have a question? Please go ahead.
Yeah, so when I see a chart like that, you know, memorability goes up, but trust for me goes way down. You know, I just see like a crazy chart and I'm like, this probably isn't accurate. You know, I don't trust these numbers. Do you know if there's been any research in that at all?
Yeah, well, I don't exactly know, but I'm sure that people study that. I'm sure this paper maybe even discusses it. But I totally get it, right? It doesn't have like trust it can be an issue, but it depends also a little bit on like there's other signals for trust, right? If like a newspaper that you trust were to publish something like that, there's context, right? So like I'm not saying this is the right thing, right? I'm basically just showing you here the alternatives, and that it's not always absolutely so easy to say, hey, just keep it minimalistic. Just don't like, not always the best thing to be absolutely pure, like a purist. And yeah, I agree. Trustworthy, which one is more trustworthy? Probably the bottom one, but maybe like, yeah, it's not, there's not an easy answer to that, right? So these guys here have studied these effects of these visual embellishments, and they actually found that there was no difference for interpretation accuracy. There was no difference in recall accuracy after a 5-minute gap. There was a significant better recall for these Holmes type charts, Nigel Holmes, the artist, of both the chart topic and the details after a long-term gap of 2 to 3 weeks. So they remembered not only the chart, but they also remembered the categories and the trend after 2 to 3 weeks. Participants saw value messages in the Holmes chart significantly more often than in the plain chart. So there's kind of like judgments, and participants found the Holmes charts more attractive, most enjoyed them, and found that they were easiest and fastest to remember. So they don't discuss trust here, which is an interesting issue. And I think that definitely, like, I don't think of a particular paper that studies trust in these kinds of charts, but that could be a cool question. So should you use chart chunk? Well, the answer is it depends. There are pros, like persuasion. You can like make a point about it. There's memorability. You can engage people much more likely. The cons is you might bias your analysis. It might be not quite perceived as so trustworthy. It is maybe a little bit harder to interpret, though this particular example didn't show a difference. There's difference in space efficiency. And then it's also like a question of effort, right? Like creating a chart with like a little monster and their teeth is much more work than creating just a simple bar chart. So like which of those two you should use is really like based on like your goals, your situation, and so on. Here's another thing that if you look at this is a chart about like PolitiFact, about like fact checking, how different politicians, how frequently they lie, and so what you can see here are these kinds of trends. But here, it's actually, this is not a terrible chart, but if we were to align them properly by this neutral point here in the middle, or this middle point, let's say half true, then kind of like we see this effect a little bit better. And so what we're doing here is we are using both position of kind of like the left and the right, how far it extends, in addition to the size of these segments. So even so, like little nuances like that can emphasize these points a little bit more. Okay, now let me talk a little bit about 3D. So 3D is like, you should generally, the rule of thumb is that you should not use 3D lightly. And what do I mean by that is, like, you should use 3D if there's a good reason to use 3D. So for example, if your data is three-dimensional, you have a good reason to use 3D. And there might be other situations. We'll look at one chart in one of these critiques later that uses 3D that is actually not that bad. But why is 3D difficult? Well, there's a couple of reasons. So first, our depth judgment is bad. So we have like, remember the Stevens psychophysical power law, that we can we are very good at like linearly correlating the physical intensity of a stimulus to the perceived sensation of the stimulus. We have linear, like we see that linearly, but depth we don't see linear. We have like a n of 0.67 where if we put this into this equation. So we tend to underestimate depth. And then we use perspectives to make something 3D. That introduces perspective distortion. And then we also usually need to use lighting and shadows and shading to make something really appear 3D. And that kind of like really makes it hard to use color reliably. And then we have issues like tilted text becomes illegible. So you should really avoid 3D until you have like a very good reason to do 3D. So just some simple examples, like 3D bar charts rarely ever make sense, right? So in all of these examples, it doesn't add anything, and I don't think this is necessarily good chart chunk. Especially at the top left one here, I can't even see some of these bars, so I can't really judge what's going on. And here it's just like a more extreme example. What you shouldn't do, like pie charts, 3D pie charts, and multiple 3D pie charts, that just doesn't make any sense. So what can you do instead, right? Like, instead of doing something like these 3D pie charts, you should just go for something like a simple like dot plot or a simple bar chart. And in this case here, like again, for showing a distribution, you might want to show like a confidence interval or an error bar or something like that. If you have like data on 3 dimensions, and I don't mean 3 spatial dimensions, but 3 like discrete dimensions, like here we have cell shape uniformity, cell size uniformity, and cell clump thickness in a 3D bar chart. It's really hard to tell like what these values are, right? And so there would be alternative representations with the size of the squares or with color, and so that would just be like a better alternative approach to these 3D bar charts here. And I should say that like the visualization community, like this is actually published in a visualization journal in 2002, isn't like there is definitely also guilty of this. This is supposed to be like a tree, like a tree visualization. So these like trunks or these beams are supposed to be tree trunks, and it's supposed to be implicit. And like that was back in the wild days of visualization research, where essentially people could just like publish crazy ideas, but didn't really ask why, or is this readable, right? So this is not necessarily a readable chart here. And I've also committed my own crimes. Like one of my first papers actually was a 3D chart. So it's not I showed somebody else's work here, but I'm as guilty of that as others. One other big issue that we frequently encounter is that we have more data than fits one chart. And how can we deal with that? Well, there's a couple of ways. We could use animations, we could multiple views, or we could do something smarter. Let me show you this particular example here. This is an animation that I can run about the fertility rate in Japan and in the United States over time, between somewhere in the, like, I don't forget, it starts in the 1940s and goes until recent years. And it shows us like the total fertility rate under the curve here. We have birth per woman on the y-axis, and then we have the age and when the women had the child on the x-axis, right? And so we can look at this and we can try to analyze it, but it's really tricky to keep track of what's going on, right? So we see changes, but we have to watch this over and over to really understand what's going on in the data. And so there's this principle in visualization that we say high-speed memory. If we have something like an animation, maybe we can just show multiple instances of that instead. And generally, that's a good principle, but it doesn't always work. So what can we do differently? So here is like the high-speed memory, the approach of simply showing every frame of that animation separately. So here we have fertility in the US and Japan for 1947, 2010, with all of these little charts. And you can see something here. You can see that like the fertility rates in both countries are changing. They're declining. You can see that there might be some kind of flip at some point, but maybe this is still not a great chart. What's not so great about this chart?
Way too many graphs.
Exactly. Exactly. There's way too many graphs. So like the change between 1964 and 1965 doesn't really matter, right? What we can maybe roll this up. Do we really need all of them? If we do something like this, where we essentially summarize like 5 years in one chart, that's maybe a little bit better, right? So we can see more of that. We can see that the fertility rate, like people like women in the United States, still like essentially there's more people in their 20s that get children in 2000 and they still have children in 2010, whereas in Japan people are much older, and overall kind of like the trends are similar. But we could also just simplify this. We could show like this in two completely different charts that don't try to combine those two things. We could say we have one chart for total fertility rate, and then we have one chart for average age when people are giving birth in the US and Japan. So these are kind of like completely different representations here, but make much more sense. And they actually contain all of the data of the initial animation, right? So it's not always and just like looking at these curves, there wasn't anything wrong with those charts, right? They used all of the visual channels correctly, but they just didn't reframe the question appropriately. Okay, see, if possible, we could also identify key historical events that might have influenced these changes. Yes, that would be cool if you have like, if you wanted to like write a newspaper article and do an interactive visualization, you might exactly do that. You might like bring in annotations. And we'll talk about this kind of stuff when we talk about storytelling. And so here's another kind of design alternative. If we looked at like this, we have a time series of scatter plots, and it's really tricky to track these plots over time. So just juxtaposition is often great, but not always. So instead, there's two alternatives here. We could just like show those two charts on top of each other with slightly different saturation or lightness. That would kind of like give us an idea of how these companies develop. Or we could kind of like do this explicit encoding with these little tails here. So just an idea that like it often pays off to think a little bit more about what you're trying to do. So I want to move on to like a design critique and an activity. So let me post a link to this. Oh, Hannah already had posted a link. Great, thank you. So today I want you to look at this this chart from a Sunday Star Times, a New Zealand newspaper from 2012. It's about most important issues facing New Zealand. We have two different charts here. They ask the same question. And what I would like you to do is, in your breakout room, look through the instructions here, and like first discuss the chart, see whether anything, like here's some leading some questions that can lead you in the right way, but you should also think about others. And then I would like you to redesign two alternatives, and then mark your best design, and then briefly note why you think it is good on the back of it if you like want to submit this for your homework. I'll start the breakout groups now. I'll keep them open for like 7 to 10 minutes, and then we'll come back to class and discuss that together. Okay. So everybody's, well, yes, everybody's back, I think. So what do you think? What's going on in this visualization? Like, what's the data that's being shown here?
I was going to say we're not totally sure, but what it seemed that we discussed in our group was that they asked some questions and they wanted to kind of gauge the perception of, well, I mean, what's the most important problem based on public perception. So.
Okay. Yeah, I think that's a accurate description. Any other thoughts, ideas here?
I think
So,
sorry.
Go ahead.
These are probably the top 4 issues for the past 10 years.
Yes, that is also a reasonable assumption. And so how's the data visually encoded here?
It looks like the proportion of respondents that like chose one category is encoded in the radiuses or in the circle's radius.
In the circle's radius, yeah. So is that a good choice?
No.
Why not?
Because like their relative size is not going to be equal. Like if you look at 2011 on top, that circle, the orange one, 14% should just be slightly less than half the white circle's area, but it's much less than just 1/2 because it's being scaled by the formula for the area of a circle.
Exactly. So this is like one of those mistakes that you see if people try to like do data visualization in Illustrator, right? They encode data by the radius instead of by the area of the circle. So that is a big problem here. Does anybody spot any other problems?
Yeah, as far as these being the top 4 most important problems, they don't add to 100. Like if you take the circles and the numbers from each year, they don't sum to 100. So there's this, and not even to 50% in some cases. So there's this huge section of other data that appears to be unencoded, and that's an issue.
Yeah, so we don't have the full picture here, right? So we're missing some data. Other thoughts? Any problems with this chart? Let me show you a slight variation here. This now is encoded, like here we have this issue we talked about, quantity encoded by diameter, not area. If we fix that, this is what this chart would look like. Sorry, I interrupted somebody. Do you want to?
Yeah, the years on the chart are also in a different location for the top and the bottom. And especially you can see that 2008 jumps all the way to the second row in the second part of the chart.
So we don't have consistent year placement. That's a very good point. So, but if you look at this chart that here fixes this and only look at this chart, are there still any other problems here?
I don't understand why one category, like one circle, is embedded in the other circle. Like it's a proportion of the other group.
Exactly. So it doesn't, this is not a part of a whole relationship or anything, right? The embedding makes no sense, and it is actually fairly tricky, right? If you look at the 2005 case, well, the 2005 case here, sorry, if you look at the 2005 case, they're about the same size, right? So it looks like the blue thing is the main problem, but it's completely occluding the red thing, even though they're about equal sized. And just imagine what would happen if these priorities were to once swap ranks. That would be even more tricky. So like, what were some kind of like ideas you guys had? How could I solve that? What would be an easy way to show that? Yeah, please go ahead.
Sorry, I was gonna say, could you just say that again? The audio kind of glitched when you were talking a second ago.
What kind of redesigns did you guys come up with? What would be alternative designs?
One was either juxtaposed bar charts, 4 bars, or stack the 4 on top of each other, and then you have to add another section that would be other to make it all add up to 100%.
Yeah.
There could be line charts across the years where you have 4 different lines.
Yeah. Any other ideas?
Pie chart. Woo.
Maybe like a stream graph or something like that, moving through time.
Yeah, stream graphs like a basically the stream graph would be the a stacked area chart. So yeah, like one simple solution is a line chart here, right? So you can just draw this as a line chart, and that's not as like that's super easy. You can see the data. You can these are independent of each other, right? And it's unnecessarily complicated here with plenty of different mistakes. And so sometimes the easiest solution is actually the better one. Any other comments about this chart before we close today's lecture?
One thing that I was thinking about at the very beginning is just it's kind of nice to have like some sort of notation about where this data was sourced from on your graphs, just because then we wouldn't be like, is this survey data or like where is this coming from? Or
yeah, that's especially important for trust. I really like some news outlets like 538, for example. They're very, very good at publishing their data, right? And so you can always go back and see exactly what they're doing. But other responsible newspapers are also doing that. They kind of like are explicit where their sources are, even if they don't even make the data available directly. But yeah, that's a good point. Okay, great. Thanks, everyone. We'll see you all on Tuesday in the lecture on D3 layouts.